Welcome to Tech Tips and Fixes. Today we're going to be looking at an old tube amp that I found in one of the most unlikely of all places, a chicken coop, believe it or not. We're going to take a look, see if we can get this thing up and running, and see what kind of sound we can get out of it. So here it is. This is an old SoundMaster public address amplifier. It actually was, last time it was used in an old church here in Canada. So I did a little research, and these old amps were built way back in 1948. I'm not sure when they started building them, but this one has two mic inputs and a phono input. The model number of this amp is a 086. I looked that up online, and actually there's a bit of information about it there. It's a 15 watt amp. It's supposed to pull about 0.65 amps of current. And you'll also notice that it was made in Ottawa, Canada. It actually was manufactured, I believe, by Northern Electric, which does not exist anymore, but I think morphed into some other electronic manufacturing companies. There's two output jacks which allow you to connect to, I think, 4, 8, and 16 ohm speakers. And I've taken the bottom off this already. I read a thing online that said that this should have a schematic on the inside of the bottom. These amps were built by a guy apparently who was a tech in the Second World War, and he bought up a whole bunch of old tubes and then started this company. And so apparently a lot of these amps were built, and they were using these surplus tubes. But anyways, getting back to the schematic, so I took the bottom off, and here's what I found. There was a schematic here at one time, but it's obviously gotten kind of bleached out or gotten wet, and the whatever ink was used has gone. So I looked online, and I did manage to find a schematic, and there it is right there. That's the SoundMaster Model 086 public address amplifier schematic, and it's a fairly straightforward tube amplifier. As you can see, this amplifier hasn't been open for many years, and there's cobwebs, even a bug, a dead bug in there. Also, you can see that all of the capacitors in there look like they're all the original caps that came with it, and so I think we can probably expect that those caps will not be in good shape and probably will need to be replaced in order to get this amp working. Well, if the bottom part of that was pretty grungy, this is downright filthy in here. You can see that it probably hasn't been cleaned out for years, and I don't know how long it was sitting there on the farm, so maybe maybe some of this came after the thing was no longer in use and bugs were climbing in and out of there. We've got a 6SC7 here. We've got a 6SJ7, or it can be a 6SH7, and here we have a 5Y3G tube. That's the rectifier tube. We've got a CAN capacitor. We've got our output transformer, I believe, power transformer over here, if I'm not mistaken, and there is our 807 output tube. So the next step, I believe, here will be to replace that power cord. The hot is going to the one side of the fuse. The other, the white, is going to the switch. And the switch is actually part of the tone control. You turn the tone control all the way down, and you switch it off. It's not the way I would normally have done that, switching the neutral side of that line, and I'll probably change that when I put the new cord on. Maybe this would be a good point at which to mention that we are talking about working on electronics that operate off of 110 volts AC, which is a dangerous voltage, and of course the internals of this amp use a higher voltage power supply. I'm not sure what the voltage is right off the top of my head right now. I think it's 345 volts according to the schematic. So, and that's DC. If you are not familiar with working on circuits, especially high voltage circuits, I warn you to be extremely careful or not to do this kind of work. So the next thing I'm going to do is, first of all, I'm just going to prepare this AC power cord. You do want to be very careful when you strip the sheath off of this extension cord that you do not nick the conductors at all. I'm just going to be very careful to score around the cable without going too deep. But again, be very careful that you do not nick the insulation on the conductors underneath there. So then you should be able to pull this off. Some cables are easier to do that than others. There we go. That's a fair one. Normally you would go through the fuse and first and then go to the switch. That's not the way they've done this here. They're not showing which side of the line here on the schematic is the neutral, but the way they've got it wired is they've got the white, which is neutral, going to the switch, and the black going to the transformer. Not the way I would usually do that. I think I'm going to change that around. I'm also going to find a place to connect up the green ground wire from this 3-prong plug. Just a quick aside on wire strippers here, for those of you who are new to working on electricity and electronics. This is my old set of Green Me strippers, which when I bought them I felt like they were pretty expensive, but these things have lasted me a very long time, and they've been great strippers. These ones actually will strip wires from 10 gauge to 20 gauge, and they have stood up to the test of time. And then I bought a less expensive, well, these are Greenlee as well, I guess, and so I haven't had them as long. These ones, I like them, but this lock sometimes kind of gets in the way. These ones actually I bought because they go from 16 gauge all the way down to 28 gauge, and that is pretty important when you're working on finer wires. You just can't do it with the other set, so that's why I have 2 pairs of wire cutters. I haven't figured out exactly where I'm going to put this ground, but I'll strip it anyways. I don't know, I don't see a lot of people doing this these days, but I still like using liquid solder flux. It's gooey, awful stuff. You want to be careful with it because it's really easy to not put the lid back on, and then you have a spill, and it's just a terrible stuff to try and clean up. Make good contact with the wire. That solder flux will clean up those wires nicely. I'm not talking about the kind of acid flux that you use on soldering pipes for plumbing or anything. That is a definite no-no, and anybody who's done any electronics for any length of time will know that already. But I assume that some of you may be new to this. So I'm going to route these wires around, figure out where to hook up the ground. One thing I should have mentioned before was just pointed out these, what they often call the death cap. These death caps, as they are called, are a basically a 0.01 microfarad cap that are connected from each side. Well, in most cases that I've seen, there's only one of them, but this one has one from each side of the AC line to the chassis ground. And this was done in older amps like this in order to have a AC connection to ground to minimize hum. They call them the death cap, as I understand it, because if they short out, then if one of them shorts out, all of a sudden you have one side of the line to the chassis, and that presents a shock hazard. So probably we're going to have to replace caps anyway, so I'm going to take these out, and if we have some hum problems later, we may have to deal with that at that point, but we're going to cut these out of the circuit. So I'm just going to take my clippers, clip those out, and that also gives me a spot where I can connect my third prong ground. So after looking at this again, there's a couple of other things I'm going to do here. Like I said before, I don't generally like to see the hot connection, the black wire going straight to the transformer. I'm going to first of all take the wire off this switch down here. That goes to the transformer. I'm going to take that off there, and I'm going to bring my hot into the fuse, and from the fuse go to the switch and into the transformer. My neutral all goes straight to the other side of that transformer winding. For those of you who are new to electronics and electricity and stuff, let me show you my trusty old solder pullet. Okay, so you can see the sticker on there. It says New Living Electronics. I've had this thing since way back in the 80s when I used to do service work, and it's stood the test of time as well. It's been good. I replace the tip every once in a while, and it's just basically a plunger type of solder sucker. You heat up the solder on a solder joint and use to remove that solder. It's got the tip there is actually a Teflon tip so that it withstands quite a lot of heat. And so basically what you do is you get that joint warmed up real good. So it's starting to flow. You could put some flux on there to just conduct the heat and get it flowing good. But you put it on there, and then you push the button on the side and it sucks the solder out. It makes it a lot easier to get that wire off there. Now I could have cut the wire off too, but I do like to clean up those connections anyways, so I like to use the solder sucker to get the old solder and any pieces of wire that were left there after I cut it off. So it's been many months since I last worked on this Soundcraft amplifier. And so here we have the bottom view of the amplifier. I made a simple strain relief using a good quality tie wrap. Obviously, when you start working on any of the wiring in these amplifiers, make sure that they're unplugged. There's the plug. I have it unplugged. And you may want to discharge the power supply caps as well, because there is about 350 volts in this unit. The power supply caps are located behind the transformer here, and I created myself a little jig a few years ago with a fairly low voltage resistor in it. This is it right here. And basically what I've got here is a 15 ohm 150 ohm 5 watt resistor. And I put test leads on the end of it. So what I do then is I use this to discharge the capacitor. I'll touch one of these leads to the ground rail here, and I'll touch the other to each one of the terminals of the capacitor, just to make sure that it drains off any charge that is still on that capacitor. It's just safe, because 350 volts is not a fun thing to come in contact with. I've had it happen before, and It can throw you off your chair if you're not watching yourself, or there's other things that can happen, and it certainly can upset your day. So we try and avoid that. Okay, so I'm going to unsolder the wire from the fuse holder. That was tricky. I managed just to break off the lead off the fuse holder. So at least it looks like I'm either going to have to work around that or replace that fuse holder. Now I'll desolder the hot wire from the power cord. Okay, there we go. Okay, I just happen to have a couple fuse holders around. Fairly similar. So here is the amp in its final form. You can see that I've replaced the 3 caps here. I tied them onto the ground bar and onto a terminal strip which I put in below there. I also changed this 4 microfarad capacitor over here. You can see the new wiring for the AC power and the fuse and the wiring to the switch, and I tested it out and it appears to work very well. Some of the tubes are a little bit microphonic, but actually not that bad. I replaced one of the old style jacks over here and put in the 1/4 inch, and here I just left in the old one, and there's the 2 old phono plugs still on there. Okay, so I've relocated over to my little audio test bench, and I've got the amp here. I've connected up the speaker into the connectors inside, just with clip leads, and I've got my Variac, so I'm going to basically plug the amp into the Variac here. So I'll plug my amp into the Variac, turn it down to 0, and turn on the Variac, bringing it up slowly. Also turn on the power to my signal generator. Okay, now that I've got my switch in the circuit, I better make sure the power switch is on. It is. slowly. Don't smell anything, no smoke. I wouldn't anticipate any problems at this stage of that. And here we come with some signal. Turn down the volume there. There we go, there's the volume on that channel. I've just got the audio generator connected into the line from the connector Let's see if the tone control is working. I'll go up to a higher range. There we go. Yeah. It's affecting it. Yeah. Tone control is working okay. Okay. So that means that basically the circuit's working, and we could probably call that complete.